Let's review how you can represent a set of numbers in actually 5 different languages. And those languages we're going to be looking at are graphs, words, inequality, set builder notation, and interval notation. Maybe you've heard of these languages before. So let me give you an example. So let's suppose I want to represent this set of numbers, all the numbers that are less than 2. First of all, let's think about who's in that set. What's a number that's less than 2? 0, -1, 1, 1.5, -4.5, 1.5, 1.6, 1.7. Actually, there's an infinite number of numbers that are less than 2. We could be listing those numbers forever. But if we want to represent those numbers or identify those numbers, we can identify them in various ways. One way is with a graph. Or a number line. And remember, a number line contains all the real numbers that are in this world. And so let me see, I want to erase that and I want to use this. But if I start looking at the numbers that are all less than 2, of course, all these 1, 0, -1, -2, -3, -4, but also everything in between those numbers. And then everything lower than -5, so -6, -7, -8. So if I'm trying to identify all the numbers less than 2, I certainly want all these numbers, and then I want all these numbers like 1.5, 1.5, 1.2, all these numbers, and I'll put the arrow. And since it says less than 2, that means I don't want to include 2, but I want everybody at least less. So I want to get as close to 2 as possible. And the way that I indicate that I'm not including 2 is I use this curly looking parenthesis to say 2 is not included, so everybody less than 2. So we have now represented the set of numbers, all numbers less than 2, with up here what we're going to call a graph. Graphing on a number line. Another way to represent all the numbers less than 2 is to use what we call an inequality. And an inequality will have an inequality symbol in it, and we let x represent the all numbers and less than 2. So that's another way to represent the set of numbers, all numbers less than 2. Another way to represent these same set of numbers, which you'll see a lot in my math labs, is something called set builder notation. Set builder notation has these little interesting curly brackets at the end, and it starts like this. First you put the variable that you're going to talk about, then you put a line, and then you take exactly what you would have had as your inequality and write it next. And the way you read this is kind of funny. You read set builder notation this way. X is such that x is less than 2. For this little line we say is such that. X is such that x is less than 2. It's like I'm going to tell you a story about x. X is the main character, and then here's the details about x. It's like a little storybook. We'll come back to interval notation. Let's look at some other examples though first. So here's another example. We're learning just how to represent a set of numbers in various different ways. This time I've given you the inequality here. And so this says x is greater than or equal to -3. So in words, the x is like saying what this represents is all the numbers or any numbers or all numbers. Did I say less than or greater than? Or greater than or equal to -3. And let's find those on the number line. Well, the stuff that's greater than -3 are all the numbers this way, so I'm shading all this in purple. I want to make sure to shade in the arrow. And since it says greater than or equal to, that means they can include -3. So we're talking about -3 and -2 and -1 and -2.5 and -1.5 and 0 and -1/4 and 1.2 and 2.5 and 3 and all these numbers in between. And because -3 is included, we use this little square bracket thing because it's included. And let's write the same thing in set builder notation. Remember, that's the wacky stuff with a little curly bracket. Who are we going to talk about? X. X is such that you just take this chunk and write it next after you write the line. X is greater than or equal to -3. And we'll come back to interval notation. That'll be the 5th language we'll learn. Let's look at another one. And this is stuff you've probably seen before. So this time I've given you the picture. And if we look at this picture, what numbers are shaded in? Well, in words, the numbers that are shaded in here are, or shown in the picture, all the numbers, but they're not less than or greater than some particular number. They're all the numbers in between. Who and who? In between -3 and 2. But since we've got these curly brackets, it's not including -3 and 2. Well, I took a lot of space to say that in words. So here's all the numbers between -3 and 2, but not including 2, not including -3. Who's in this set? -1, 0, 1, 1.5, -2, 1.9999999, but not 2. -2.99999, but not -3. So that's how you say that set of numbers in words. As an inequality, we're going to use this in-between idea. And to write this as an inequality, what you're going to do is you're going to put x between the two numbers that it's between, -3 and 2, and then in between we're going to put less than signs. X is between -3 and 2. It's on the big side of -3 and on the littler side of 2. All our x values are bigger than -3. They are and less than 2. That's kind of a interesting way to write it, to have to think about it. Now, to do set builder notation is really easy after you've already got the inequality, because again, you have these little curly brackets. You're going to put x as such that, and you're going to take exactly what you have here and write it next. -3 is on the little side of x, and x is on the little side of 2. We'll come back to interval notation. One more example. This time you've been given set builder notation, and we're familiar enough with it that the easiest thing might be to go right to inequality notation. So -2 is less than x, but x is less than 5. And when the inequality looks like this, we know we're talking about numbers between two numbers because the x is stuck between two numbers. So all numbers between -2 and 5. But this time we are including 5 because it says less than or equal to, including -2, sorry, and not including 5. So including -2 because we have this less than or equal to, but not including 5. So what does that picture look like on the graph? Well, we know we want all the numbers between -2 and 5. Since it says x is greater than or equal to -2, we want a square bracket here. And since 5 is not included, we're using a curly bracket there. That's how we show not including. This is how we show including, with a square bracket. All right, almost at interval notation. Let's look at our next example. In the next example, I give you interval notation. So let's talk a little bit about interval notation and how it's set up. In interval notation, you have your lowest number in your set that you write first. There's a comma between, and you have your high number. And then next to the low number, you're either going to have a square bracket for included or curly bracket for not included. And I'll explain this more in a moment. And over on the high number side, you're going to have a curly bracket if it's not included, or a square bracket if it is. And let me diagram that a little bit more. This curly bracket means not included. That's what curly means. And square means included. And that's kind of the little template, the formula for interval notation. So let's look at what we've been given and see if we can figure it out. So -1 must be our low number, and because it's curly, that means we're talking about a set where -1 is not included. And our high number in this set is 5, and because it has a square bracket, it must be included. So we've got the low and the high, so the set includes everybody in between. So interval notation identifies a set by telling you who's the low, who's the high, and then you include everybody in between. So now that we've got this picture, let's say this in words. This is all the numbers between who and who? Numbers between -1 and 5, right? And what about not including -1, but including 5? As an inequality, remember, if we've got numbers stuck between, we want to write x between the numbers that it's between. And then stick in our less than signs. There'll always be less than signs that we'll stick in. Let's see, is it less than or is it less than or equal to? It looks like for this one, it's just less than. And for 5, it's less than or equal to. And then set builder notation. What do we know? Curly brackets x. Going to tell you a story about x. What's the story? This is the story about x. You drop that in. -1 is less than x, and x is less than or equal to 5. So now that we've learned interval notation, let's go back and fill that in for all of the examples that we've done already. So we'll go back. So what would be interval notation here? Oh, it's sliding. What would be interval notation? Well, it's real easy to see what interval notation is when you look up at the graph. Look at all of our numbers. Oh, my graph slid, so everything's lit. Oh, great. Select. Now we can move it back to where it was. Sorry. It's supposed to be between -2 and 5. There they go. Okay, so the interval notation here would be, what's our low number? Our low number is -2. Let me draw, if it'll let me. -2, not with that. Draw with this. -2. And our high number in this interval is 5, at least it was. And so bracket and curly, because -2 is included and 5 isn't. I'll try not to move the screen as much when I go back to the next one. Okay, here we go. We want to write this in interval notation. We just look up at the graph, and what do we see? Our low number in this set is -2, -3. Our high number is 2. We put a comma between them. -3 is not included. 2 is not included, so we use curly brackets. Let's look at our next set. So the low number here is definitely -3, and it's included because it was greater than or equal to, and we have our square bracket. But what's our high number? This is going on forever. So something goes on forever. The high number is infinity, and that's the symbol for infinity. I'm sure you've seen it before. And infinity can never be included because we never reach it, so infinity always has a curly. So in interval notation, it's all the numbers from -3 all the way up to infinity, and that's what we see in the picture. In other words, all the numbers greater than or equal to -3. And then one more. So we want to write this as interval notation. Let's look at what we've got. All the numbers less than 2. That means our low number this time is infinity this way, but infinity in the negative direction. So we call infinity that way negative infinity. So our low number is negative infinity, comma, how high does this go? It goes up to 2. Infinities can never be included. We can never reach them. And this says less than 2, so we put a curly bracket here at 2. So that's a review on the ways that we can represent a number basically in these different languages. And I'm sure this is stuff you've seen before. And in particular, interval notation will be real important as we go down the road.